All right, welcome back to another one of Mr. Martin's math videos. This is the part 2 video of section 6.3, looking at solving linear equations, just different types of equations, specifically equations with variables on both sides of the equal sign in different forms, and combining it with brackets and other types of algebraic steps that we saw. The main rule that we're looking at that we introduced last video is variables on one side, constants on the other. It doesn't matter which side you're isolating the variable, whether the variable is on the right, like in this example here from last class, or the variables on the left, like this example here from the same set of notes. Just as long as the variables are all on the same side first and then the constants on the other side, you move these using addition and subtraction, and then from there you isolate the variable using that last step of either dividing or multiplying to separate the coefficient from the variable itself. So we went through a number of problems together. And then we did an activity today. There was an activity that was in your notes for homework. Hopefully that's going well. And this is the next part of the notes. So let's take a look here. Now we're looking at some tougher problems here, largely tougher just because they are dealing with fractions. But in some of these questions, you can actually deal with these fractions quite nicely. So for example, here, I'm not going to distribute the fraction inside of the brackets for this question. I'm actually, because 1 over 9 goes into 1 over 3 quite nicely, I'm going to divide both sides of my equation by 1 over 9. Okay, that's going to cancel out the 1 over 9s over here, leaving me with 2m minus 16. Again, I did not have to distribute the fraction inside of that side of the equation. Then over here, all I have to do is 1 over 3, 1/3 divided by 1 over 9, and it gives me 3. Okay, so that gives me 3 times 2m plus 4. Okay, so now I only have to distribute one number instead of two number, and that number that I have distributed now is no longer a fraction. It's a 3, which is way friendlier. So 3 times 2m is 6m, and then 3 times 4 is 12, and this is still equal to 2m minus 16. All right, now so now I'm ready to just bring the variables on the same sides, variables on one side, constants on the other. I'm going to bring the 2m over to the right side, so I'm going to have my variables on the right side just because I want that positive coefficient. That means the constants are going to be on the left. So I'm going to subtract 2m on both sides. That's going to cancel that out. Constants on the left, so I'm going to minus 12 on both sides here. All right. And that's going to give me 4m is equal to negative 38. Last step, divided by 4 to separate that 4 and the m, which leaves me with just m by itself. And negative 38 divided by 4 is 7. Oh, no, sorry, negative 9.5. Why is it 7? Negative 9.5. And that's your answer for that one there. Or, if you didn't want a fraction, you can turn that into a fraction pretty quickly there. Okay? So there are ways to avoid fractions even in these questions. Okay, so be looking out for those questions. Okay, however, that's not the case for every question. So for example, in this situation, what you want to do in this situation is make sure that you're dealing with common, actually the first thing I'm going to do is just bring the variables on one side, constant on the other. I'm going to move the negative 1/2 y over to the left-hand side by adding it to both sides, which cancels it out. That means my constants is going to be on the right, so plus 1 over 6. Let me rewrite that. Plus 1 over 6 plus 1 over 6. All right. So that's going to give me 5 over 6 plus 1 over 6 is 6 over 6 is equal to 1. Okay. And then on this side here, so Sorry, this canceled out, so all I have left is this. Now I need to add these two fractions, okay, because right now I have 2 over 3y minus 1 over 2y. Okay, so first I need common denominators. So I need to multiply the top and the bottom here by 2, top and the bottom here by 3. That's going to give me 4 over 6y minus 3 over 6y is equal to 1. And that's going to equal 1 over 6y is equal to 1. Then I divide both sides by 1 over 6. And 1 over 6 goes into 1 nicely. But you can see it like this if you want. It's 1 over 1 divided by 1 over 6, which is like saying 1 over 1 times 6 over 1, right? We multiply by the reciprocal, which is just equal to 6 over 1, or 6. And that would be your final answer there. Okay, so even in fraction form, remember, all we're doing is adding, subtracting, multiplying, dividing. You guys know how to do that with your fractions. So just don't get freaked out. Take it one step at a time, one fraction at a time. One fraction at a time. And again, when dealing with fraction questions, I suggest you have a little section for side calculations over on the right. Okay, just to kind of keep your algebra clean and do your fraction calculations in a separate part of your paper. Okay, your turn. I want you guys to give this one a shot, get through it, and then unpause the video and we'll go over it together. All right, hopefully that went well for you. Let's take a look again. Here, again, 1 over 5 actually goes very nicely into 3 over 5. Okay, and you'll learn to recognize these as you go because they have common denominator. So what I'm going to do, instead of distributing my fraction, even though this wouldn't be the end of the world because I'd have a common denominators everywhere because it's over 5, but I'm going to divide both sides by 1 over 5 instead. Okay, that's going to cancel that. I'm left with 4y plus 3 is equal to, all right, and again here, my side calculations, I have 3 over 5 divided by 1 over 5 is like saying 3 over 5 times 5 over 1, right? Multiply by the reciprocal, and that's going to equal 15 over 5, which is equal to 3. Okay, so that works out nicely. So this leaves me with 3 bracket 4y minus 1. Now I only have to distribute a 3 instead of a 3 over 5, which is a little bit cleaner in my work. So I'm going to start distributing. 3 times 4y is 12y. 3 times negative 1 is negative 3, and that's still equal to 4y plus 3. All right, now from here, hopefully you're comfortable with what you're doing. You need to have variables on one side, constants on the other. I'm going to bring that 4y over to the right-hand side by subtracting 4y on both sides. All right, that's going to allow me to have a positive coefficient on the y. And since the constants now are on the right side, on the left side, I'm going to add plus 3 to both sides, which cancels out this. And that's going to give me 6 is equal to 8y divided by 8 divided by 8. And of course, we want to simplify that fraction. So y is equal to 3/4. Okay, hopefully that's what you got. All right, you can even have side calculation here. There's lots of space in this question for you to give that a shot. Okay. Here, you know, it doesn't really change much when it comes to decimals. I think decimals are much easier for you guys to deal with than fractions. In some ways, they're a lot easier because I think you guys are less hesitant to use your calculator when it comes to decimals, which, you know, makes it more likely you'll get it correct for some of you. And so here, again, you're just variables on one side, constants on the other. Here, it's only 3 terms. And so I'm going to add 0.2w on both sides. Okay, that's going to cancel out, which leaves me with negative 1.1 is equal to 0.5w. Then I divide both sides. Now I separate the variable from the coefficient. You only do this step here, separating the coefficient from the variable, once all of the terms with the variables have been consolidated into just one term on one side of your equal sign. Okay? I wouldn't want to do divided by 3 on both sides at this stage here. That wouldn't make sense, and that wouldn't help me find my final answer here. So, 0.5 divided by 0.5 is 1. 1 times w is w, so I essentially have canceled out the 0.5. And then negative 1.1 divided by 0.5 is negative 2.2. All right, that's your answer there. Okay, same idea here as before. Variables on one side, constants on the other. So I'm going to add 16.2c to both sides. All right, that's going to cancel that one. So I want my variables on the left. That means my constants go on the right. That means I'm going to subtract 4.3 on both sides. And what am I left with? On the left-hand side of my equal sign, I'm left with 31.5c. And on the right-hand side, I am left with 12.6. From there, divide by 31.5, divide by 31.5. And c is equal to, and this is what I mean when in terms of not hesitant to use your calculator, because here I'm not looking to reduce this fraction. I just plug it in and I get my answer in decimal form, and I'm happy with that, right? Let me just fix this window here. Nope, that's not what I want. There, that's what I want. So I can hide it. All right, so that's last question here. In this situation, you have a couple options to you. You can get common denominator here. And if you get a common denominator here, you can actually cancel out the denominators and then just go from there. You can also cross multiply this situation here, which essentially you end up doing the same thing. Here I'm going to cross multiply to solve for this. So it's 6m minus 3 would be times 3 is equal to 4m minus 1 times 5. So let me rewrite that out. 6m minus 3 is equal to 5, 4m minus 5. Now, just pause here and think about if we would have gone the other approach. Okay? If we would have done the other approach of getting a common denominator, what would you have multiplied on the top and bottom on the left-hand side to get a common denominator? The common denominator would be 15, right? So you'd have multiplied both the top and the bottom by 3. Well, see what you get here is 3 times 6m minus 3, which is what we end up doing here. And then on the right-hand side, you would have multiplied 5 to the top and bottom. And it would have been 5 times 4m minus 1, which is what we have here, right? And so you're essentially, that's what you're doing. You're doing the same thing mathematically. 3 doesn't go into 5, so I'm not going to divide 3 on both sides. I'm just going to distribute everything and then go for an answer there. So 3 times 6m is 18m. 3 times negative 3 is negative 9 is equal to 5 times 4m is 20m. And 5 times negative 1 is negative 5. All right. Again, I want my coefficient to be positive, so I'm going to subtract 18m on both sides of my equal sign. That's going to cancel that out. So since my variables are going to be on the right-hand side of the equal sign, I want my constants to be on the left-hand side. So I'm going to add 5 to both sides. I'm going to move that negative 5 over to the left-hand side. So that cancels out. And what am I left with? I'm left with 2m on this side, and I'm left with negative 4 on this side, and this is going to come out quite clean, actually. Divided by 2, m is equal to, it's not divided by negative 2, it's just divided by 2. It's equal to negative 2 is my final answer. M is equal to negative 2. All right, so there's a couple of questions there. If you want, rewind the video, try to solve these on your own, and then, see if you get the same answer as I did here. Okay, now let's look at a couple word problems. Here, so for example, saving buddies. So Alan has, so these are saving buddies in terms of two people that save money together and help each other out in finances. It's actually helpful to have someone that you can talk about finances with to make sure that the decisions you're making are best practice and are healthy. So you want to have someone that you're talking to. It could be a family member, a friend. The more the better, so that you can be learning from other people who have more experiences and new insights into money that you don't have, and also you're also able to contribute to the financial success of those around you and the well-being of those around you. So definitely encourage you guys as you move forward and make money in the future to have these conversations. Oftentimes we don't talk about money because it's not seen as proper, but it's good to talk about. Alan has $35.50 and is saving $4.25 a week. Ava has $24.25 and is saving $5.50 a week. And how many weeks from now will they have the same amount of money? So let's come up with an equation here. So first I want to know Alan's total. Okay, Alan's total, right? The equation for Alan is what? He starts off with $35.50, and every week he's adding plus $4.25 every week. So after 1 week, he's got $35.50 plus $4.25 times 1, right? And then after 2 weeks, it would be times 2 and so on and so forth. So that's a nice equation for us. Ava starts with less money, but is saving more each week, right? So eventually their amount is going to converge and she's going to surpass him because she's saving more, even though she started off with less, which is a powerful finance rule. Even if you have an initial amount that's larger, if you're able to save more in the long run, you will do well. So she starts off with $24.50. Let me stay in the color that I was doing this in. This $24.50. And each week she's adding $5.50. So times W. Okay? And 1 week in Alan's world, this is obvious, but maybe not obvious mathematically, but obvious when I say this. But 1 week in Alan's world is equal to 1 week in Ava's world, right? So we can use the same variable here because it's 1 week for both, okay? If one experiences 2 weeks in time, unless the other person is in a spaceship traveling near the speed of light, the other person has also experienced 1 week in time. So we have one variable here. Now the equation wants us to know how many weeks, what is the value of W, right? W equals question mark, that's what I'm solving for. And how many weeks will they have the same amount of money? Okay, well, Alan's going to have, this is the equation for Alan's amount of money, and this is equations for Ava's amount of money, and we want to know when are they equal to each other. So algebraically, how we represent this is we make the total for Alan equal to the total for Ava. When will the amounts represented in both equations, when will both equations be equal to each other, right? Because we know that we can graph these, right? These are just linear equations, and they're going to give us a line if we were to graph them. And essentially, you want to know when is Ava's graph going to surpass Alan's graph, or when are the two lines going to cross each other? Because that's when the value in both of their bank accounts are equal to the same thing. Okay, and so this is their equation, and then once you set it up, you're just solving this like any other algebra problem. Variables on one side, constants on the other, going from there. So I'm going to subtract 4.25W on both sides. All right, so that's going to cancel that out. All right, and because I have my variables on the right-hand side, I want my constants on the left-hand side, so I'm going to subtract $24.50 on both sides. That's going to cancel that out. So what am I left with? 5.5 minus 4.25 is 1.25. W is equal to, what is that, $11? That is $11. $11. Okay, so there's an $11 difference between their initial starting points, but Ava saves $1.25 more per week. So how quickly will she be able to make up that ground, the $11 between them? Well, divide that $11 by 1.25, the $1.25 more that she's saving. And you get an answer that by week 9, essentially, so 8.8 weeks, so the same amount of money. At no week will they have the same amount of money, but after 9 weeks, she'll have surpassed the amount of money he has saved. Okay? And this is the powerful part here, after 8 weeks, which is like 8.8 weeks is like, let's say that's 2 months, okay? But after 2 months, she'll have more than him for the rest of her life, because even though she started with less, she's adding to her account more regularly, okay? And that the amount that she's going to have more than him is just going to increase as time passes. All right? Okay, this question here, we actually did on a practice quiz today. Okay, so actually I'm going to skip this one. If you want to see this question while you were in class today, so that will help you. Otherwise, you can look at the quiz paper in OneNote, and I go over the question. You can see the work there. Obviously, there's no audio. I don't think we were recording this at the time either, but you'll see the work there, and hopefully it'll make sense for you. But that's how to set it up. We did it as a quiz today, so I'm not going to go over the same question. And last question here, the beast. All right, in this question here, like I said here, if you get a matching denominator, okay, if everything is over 3, then you can actually multiply. So we want to have a matching denominator here, okay? So that's the key to solving something like this. So I multiply this one by 2, okay, which is going to give me 2 bracket 3y plus 4 over 10, okay? And then here I multiply, that's in brackets, right? The numerators are. And this is times 5, because my common denominator is 10. I want a common denominator across my equation, okay, for this example. So this is minus 5 bracket y plus 2 over 10 is equal to 4y minus 1 over 10. That one's already over 10, okay? Now, in order to get rid of my denominators here, I just need to multiply the entire sides, both sides of my equation, by 10. So I'm going to multiply 10 on this side. That's going to cancel that out. I get 4y minus 1. And this 10 actually cancels out both of those 10s there. So I'm left with 2 bracket 3y plus 4 minus 5 bracket y plus 2 bracket equals 4y minus 1. Now here we want to distribute, okay, to get rid of the brackets, and then we'll be able to consolidate our variables and constants onto the left-hand side or the right-hand side, respectively. So 2 times 3y is 6y. 2 times 4 is 8. Negative 5 times y is negative 5y. And negative 5 times 2 is negative 10, is equal to 4y minus 1. I'm going to bring my y variables to the right-hand side, because that's going to give me, and my constants to the left-hand side of the equation. So I'm going to do minus y, and then, actually, no, before this, I'm going to combine all my greatest common, my like terms on my left-hand side of my equation. So that together, these two together, will give me y, and then these two together give me minus 2. Y minus 2 is equal to 4y minus 1. Then I subtract y on both sides, and I'm also going to add 1 to both sides. So that cancels this and this out. I have my variables to the right, constants on the left. Here I am, stuck in the middle with you. negative 1 over 3. Okay? So that's the beast, as we call it. Okay? That's a tough question here. There might be a question like that in your homework or in some of the extra practice we're going to do over this section. Okay, I think this is the last section of the textbook, so that means there's a test coming up. So if you have not been keeping up with your homework, now's the time to really get crunching on Chapter 6 because the test is approaching soon. And we're going to have one more chapter we're going to do this year, and then that'll be it. Then we're going to call it. And so make sure that you stay. And the last chapter is super interesting. It's all about finances, as you already know. I enjoy teaching and talking about finances and very relevant stuff. So your homework, so go through, can you model a problem with linear equations involving unknowns on both sides? Okay, we did a couple examples of that. One was this surface area question, which we did in the quiz. The other one was the money question here. Both of those had that. And then, can you use multiple strategies to solve linear equations? Okay, we use distribution sometimes to get rid of the brackets, common denominators, dividing, both sides before distributing, especially if there's a fraction there, those kinds of things. Lots of different strategies, lots of different approaches. Your homework, due Wednesday. And this will be on Teams as well, is this right here, 1 to 9, 10, any 3 of number 10, and then 11, 12, and 14. If you have any questions, just post them in the comments below or in the homework questions channel on our Teams, and we will see you next time. Goodbye.